Hello everyone, my name is Nuraini SG and my student ID is 1120211199. And today I'm excited to present my project on analyzing the top 100 high frequency words in non-Hodgkin lymphoma articles from PubMed. This research guided by my teacher Jingdoang used text mining to uncover key themes in lymphoma research. Let's dive in. A non-Hodgkin lymphoma or NHL is a group of cancers affecting the lymphatic system with diverse symptoms and treatments. PubMed hosts thousands of articles on NHL, offering a wealth of knowledge. But how do we make sense of all that data? My project analyzed 10,000 PubMed articles titles to identify the most frequent words and their relationship. By doing this, we can spot major research trends like treatments or subtype and help guide future studies. I use Python and visualization tools to process this data, creating a clear insight into the NHL research landscape. So let's get started. First, we need to open the file that already been given in the Tron class. Okay, let's get started here. Here is the file that I opened from the Tron class, the 2_0 PubMed info extraction multi-line parse to Excel. Yeah, and then you can load the data, load the data. The input file is PubMed non-hotkey set here, as you can see. And then we parse it to the Excel file into the output file name PubMed non-hotkey set parse to Excel XLS. And then after you run all of it, after you run the file, and then here it can auto download the file, but I don't need to download it again because it will make a copy because I already saved it. Okay, and then we move to another step. Open another file with the 2_1 data here to process the data we just got, and then we can load the data file path. I'm sorry. Here, the file path PubMed non-hotkey set parse to Excel XLS that we just make before this. And then after we load the data, we can just run the code and we got this. We got this top 100 words and their frequency saved to PubMed non-Hodgkin set parse to Excel. No stop words, no cancer. Top 100 high frequency CSV. Yeah, here. Um, yeah, I forgot to say that you need to compute the frequency of words and filter it to make the data more clear. So here, I already compute all the data. And first, I want to create a bar chart for the top 100 high frequency to make it more understandable for the audience. Here, I already make the chart data, but I think it's not enough. So I just followed the teacher's step by using the diagram. But the diagram that the professor gave is really crowded. So I changed the code to make it more clear. I improved the code into this one. It has information. It has more clear diagram and it has information in the bottom right side about the top 5 because it has a different color from the others. Like this one, lymphoma is orange. Yeah, here a Hodgkin is green and primary is purple. Patient is brown. Yeah, something like that. I also make a diagram matrix heat map of word co occurrence top 30 words. I'm sorry, I just plugged my laptop. And then here is the code. And then this is for the matrix. Yeah, that's all. And I already got the output file here for the top 100 words non-Hodgkin lymphoma CSV, and I need to send it to the generative AI like DeepSeek, Chat GPT, or Grok AI. But I decided to send it to DeepSeek and Grok AI instead because all of this. I made all of this code using ChatGPT, the help of ChatGPT, and I think I want to do something else with DeepSeek and Grok AI. So I will send this to the DeepSeek and Grok AI. And here is the comparison between DeepSeek and Grok AI. Let's see if it makes sense. Not this one. This one. Yeah, this one. Let me check it first. Yeah. After I upload the file, it just gave me an information like this. So it produced a conceptual network diagram sketch which was non-interactive and lacked clear frequency data. The diagram was difficult to interpret and did not effectively convey words relationship or their significance in NHL research. Meanwhile, the Grok AI, after I upload the file, they make something like this. Wait, they uh Grok AI generate an interactive HTML report with a word cloud and a bar chart, both displaying all 100 words. The words cloud use a scatter plot with text size scaled by frequency, and the bar charts show frequency distribution with tooltips revealing exact count on hover. This interactivity made it easy to explore word relationship and frequency, significantly aiding understanding of NHL research teams. So the conclusion of this comparison is Grok AI outperformed DeepSeek due its effectivity and interactivity and visually intuitive output. ChatGPT was not used for the visualization but contribute to the code foundation in indirectly supporting the final output. So, for the code generation, ChatGPT and Grok were used to develop the visualization code. ChatGPT provides simpler, more straightforward code, which was easier to understand and implement, making it the ideal for quick prototyping. Grok, however, generated more complex but highly detailed code, incorporating advanced features like interactive tools and responsive design in the HTML report. By combining ChatGPT simplicity with Grok details, approach and optimized HTML visualization was created, balancing usability and functionality. DeepSeek was not used for the code generation as it responds focus on analysis rather than coding support, and I don't really like the DeepSeek, so I prefer the Grok for visualization, but for the code, I I tend to use the ChatGPT instead because it's more simple. And yeah, we are finished. So the conclusion of this project is successfully extract and analyze the top 100 high frequency words from 1000 PubMed articles on non-Hodgkin lymphoma by focusing on words frequency and co-occurrence in the article titles. The study provides a foundation for identifying key research areas and their interconnection. Future works could extend this analysis to abstract, incorporate temporal trends, or apply advanced natural language processing technique to uncover deeper insight. The words such as non, lymphoma, and Hodgkin reveal key themes in NHL research, including disease subtypes, treatments, diagnosis, and anatomical sites. Grok's interactive visualization, words cloud, and bar chart effectively illustrated this relationship, making it the most effective AI tool for this task. While ChatGPT simple code complement Grok details implementation. And then a DeepSeek non-interactive network diagram was less helpful. The final HTML report combining ChatGPT and Grok contribution provide a comprehensive and interactive analysis suitable for submission to the Tron class. Okay, thank you. That's all uh, for my explanation for this project.